Just 5 years ago, humanoid robots were stuck in labs doing one-trick demos. But in May 2025, we saw them stepping into a boxing ring in China, throwing punches, dodging hits, and holding their balance. Some are now even running half marathons. From clunky animatronics just 15 years ago to machines that can run, lift, and think, humanoids are evolving fast. But how close are we to building truly human-like robots? Let's break down the 5 levels of humanoids, see where we are now, what challenges are next to solve, and what big mistake to avoid as we approach the last level. By the way, there's no official scale, so this is my own take on it, based on my research and experience working with robots. Let's jump in. Level 1, animatronic stage. This is where it all started. Robots at this stage are essentially mechanical puppets. Pre-programmed motions, no sensor, no awareness. Just motors repeating motions in a loop. Think of Da Vinci's Knights or Disney Hall of Presidents.
70 years ago, our fathers brought forth on this continent a new nation.
No real robotics yet, but this era taught us something important. Design matters. How a robot looks and moves affects how human responds to it emotionally. I bet you thought this Disney Hall looked creepy. That emotional reaction sparked lots of research in design, ethics, and films. I'll link some papers in the description, but basically, the more a robot looks human, the more people feel attached to it. Level 2, basic autonomous humanoids. We start getting into real robotics here. These robots can walk, balance, and do simple tasks like talk and pick and place. But only in controlled environments. You have to tell them exactly what to do and how to do it. This is where we saw robots like Nao and Asimo. The big step here? Bipedal motion. Walking on 2 legs is way harder than it sounds. Even humans take about a year before we can get the hang of it. For robots, it's a constant challenge. It needs to keep its center of mass within the support polygon, continuously process sensor input, compute inverse kinematics to adjust its joint position, plan its foot trajectory, and adapt all of this in real time. And even today, walking on uneven terrain is still a challenge for robots. Level 3, cognitive humanoids. Here's where things start to feel smarter. Level 3 robots can recognize faces, understand simple language, and make decisions based on their environments. They use tools like laser scans and RGB cameras to see their surroundings, algorithms to map it, and reinforcement learning to improve their behavior through trial and error. Robots like Optimus and Figure AI are currently at the start of this level. Why only the start? Because real-world interaction is still limited. Sure, you can find impressive videos of these robots operating in lab. But what about navigating in a busy city, with kids running around, bikes zipping through, and a small dog jumping out from behind a bench? These robots are not ready. Even at events like Tesla We Robots, Optimus was partially teleoperated. We're not yet at the point where these robots can operate independently in an unstructured, dynamic, human environment. There is one more major hurdle engineers need to clear before level 3 can be considered mature. Dexterity. I recently attended a humanoid robotics event and spoke with representatives from Humanoid, Kinesis Robotics, and Jabel. All of them said the next big challenge to solve is reliable hand control. For a robot to interact with our world, it needs to grasp, manipulate, and explore physical objects as naturally as humans do. That means fine motor control, real-time tactile feedback, force sensing, adaptive grip strategies, and fast reflexes when things go wrong. Dexterity isn't just about picking up a cube. It's a huge challenge and a whole video of its own. But before we get ahead of ourselves, let's keep climbing. What comes after cognitive humanoids? Level 4, adaptive humans. We're now entering uncharted territory. This is where things get interesting. Level 4 humanoids don't just move through the world, they adapt on the fly. They could walk into an unknown environment and start figuring out things on their own. The key here is generalization. being able to transfer learned skills across different contexts and learn new skills from observation. Imagine a humanoid doing house chores one day and assisting in disaster zone the next, all without needing to be reprogrammed. That's adaptive autonomy. They would also collaborate with humans using clear language, or C++ if you're a robot friend.
Amika, wake up. What?
And most importantly, they read human body language, identify emotions, and respond appropriately. They don't just recognize a situation, but make decisions with that emotional context in mind, which is super important for social creatures like us. Take Atlas, for example. Right now, it can do some crazy flips and dances, but it's still following a plan. It doesn't understand why it's jumping or if it should. Level 4 is about giving that understanding. Level 5, synthetic human. This is the final level. The point where humanoids stop being tools and become almost indistinguishable from us. At this stage, we're talking about self-driven, fully autonomous synthetic humans. They wouldn't just assist us, they would have their own values, lifelike skin, facial expression, and even a sense of purpose. This is the kind of vision you see a lot in sci-fi, like Detroit Become Human or Murderbot. Humanoids with flesh-like skin, emotions of their own, and artificial consciousness. They wouldn't just look humans, they would feel human. At this level, they're no longer just machines, but they'll become teammates, caregivers, or even explorers, operating alongside us. They would likely surpass us in some areas, like memory, precision, or resilience, but still show curiosity, relatable emotions, and moral reasoning. Getting to this stage is a huge challenge across multiple disciplines. We're talking about advanced materials science to create soft skin, artificial muscles, and even synthetic nerves to feel touch and temperature. Everything would also need to shrink. Look at your pinky finger. Imagine how small a motor needs to be to fit in. And beyond that, we'll need new kinds of computing, not just fast processor, but brain-like systems. That's where neuromorphic computing comes in. But getting to this level also raises serious questions about rights and identity. No, humanoids will never be humans, but this is not relevant. These synthetic humanoids will be sentient. To recap, that means they are self-aware, feel emotions, and make independent decisions. So we'll need to think carefully about their place in society and avoid repeating the mistake of the past. This is actually discussed in Star Trek Next Generation, The Measure of a Man. They had a trial to decide whether Data should have rights or simply be considered as a machine. If you're curious about what it means to be sentient, you should watch this episode. As I was developing this humanoid level, I kept wondering, if we ever built synthetic humans, what would they want to do? Would they want to serve some greater purpose? Or would they be forced to think that? Would they have free will, be able to disobey, or spend a full week watching TV if they wanted to? Or would they always have core values deeply embedded, designed to guide them towards service and cooperation? Let's be honest, companies are not going to spend billions to build humanoids just for fun. Behind every humanoid, there is a business case. As companies keep pushing towards level 4, it's pretty clear what's coming next. First, humanoids that can handle a variety of tasks reliably, and then humanoids that can recognize intent, understanding why you say something like, "help me," without needing every detail explained. But here's the thing. Every step forward becomes exponentially more expensive. I can't help wondering if it will even make financial sense to fully reach level 5. We probably won't see a world filled with synthetic humans. Maybe we'll see a mix, with most robots sitting at level 4, doing the bulk of the work, with one sitting at level 5 leading the pack. And that leaves us with the bigger question. If we ever do create synthetic humans, what role would they really play in our society? And more personally, would you want one in your life? Let me know in the comments, where do you see this all going?